What's up everybody? Today we're going to be going over the LeetCode problem, valid parentheses. First, we'll write it out. Next, we'll turn it into code. And finally, we'll go over the time complexity. So, let's do it.
Let's get started. I went ahead and copied down everything the LeetCode gives us. And basically, it just tells us that we're given a string and it contains only these characters. And it also gives us some test cases that I'm going to go over in a sec. So, for this problem, we're basically going to divide the characters into two unique groups. We're going to call these the opening characters because they open a set of characters, and then we're going to call these characters the closing characters. And so the gist of the algorithm that we're going to use is each time we see an opening character, we're going to push its corresponding closing character onto the stack. And then the next time we see a closing character in our string, we're going to check to see if it matches the thing on the top of the stack. And if it does, we will continue, and if it doesn't, we will return false. Let's do an example. The first string we see is a parentheses. So, like I said, we're going to create a stack, and we can let this rectangle represent our stack, and we're going to push the corresponding closing character for the character that we're currently on in the string. And basically what that just means is that we're going to push a closing parentheses. And then so we move forward. The next character we see is a closing parentheses. Each time we see a closing character, we are going to pop from the stack. And we are going to check to see if the thing we just popped matches the character that we're currently on up here. And these two characters are exactly the same, so we don't return false. And because we're at the end of the string, we will return true. Continuing on to the next example, here the first character we see is an opening character, so we're going to go ahead and push its corresponding closing character onto the stack. Next, we move forward and we see a closing character, so we're going to check to see if these two characters match. Pop from the stack, and we see this character here that we just popped off does match our character that we're currently on in the string, and so we don't do anything. Continuing on, we have an opening square bracket, so we're going to push a closing square bracket onto the stack, and so we continue, and now we have a closing character, and so we're going to pop from the stack and check, does this closing square bracket match this closing parentheses? And they don't, so we're going to say return false. On to the next example. Here we see a opening parentheses, so we're going to go ahead and push a closing parentheses onto the stack, move forward. We see a closing bracket, and so we pop from the stack. Does this closing parentheses match a closing bracket? No, they don't, so we return false. Finally, we can do this example, which has nested brackets. The first character we see is an opening parentheses, so we push a closing parentheses onto the stack. The next character we see is an opening bracket, so we push a closing bracket onto the stack. The next character we see is a closing character, so we're going to go ahead and pop from the stack and check, does this character here match this character here? It does, so we don't do anything. The next character we see is a closing character, and so we pop from the stack. We see, does this character here match this character here? And they do, and we reach the end of the string, and so we return true.
Alright, so let's start coding. If we remember back to our written solution, we know that we needed to use a stack of characters. I just called it scene because it's the characters that we've seen so far, and actually different from our written solution because our computer isn't as smart as our brain. We need to keep track of kind of the mappings between opening characters and closing characters, and so we're just going to use a hash map for that from character to character. I'm going to call it opposites. And essentially, I'm just going to put in each relationship of characters. Alright, so now that we've taken care of that, we can go ahead and get into the actual algorithm. We know that we want to use a for loop because we want to go over each character inside the string. And now that we've done that, let's grab the current character we're on. Now that we have the current character, we can see if it's an opening character or a closing character. And we can do this by seeing if opposites dot contains key, current character, then it is an opening character because all our keys in our map are opening characters. And if it is an opening character, we remember that we want to push the corresponding closing character onto the stack. And we can get the corresponding closing character by saying opposites .get cur. Else, which is saying like if we get a closing character, we need to check that the thing on top of the stack matches our current character. If it doesn't equal cur, then we need to return false. At the end of the for loop, we can say return scene.isEmpty. And we say this because the string could potentially still be valid here, but then they could put a lot of opening parentheses or any opening character. And so we need to make sure that the stack is empty. Similarly, we need to make sure that in this if statement, we're not trying to pop an empty stack, because if we do that, we'll get an error. So we say scene.isEmpty or scene.pop does not equal cur, we return false. Once again, for each character in the string, we get the current character. We see if it's an opening character. If it is, we push it onto the stack. If it's not an opening character, so if it's a closing character, we check, is the stack empty, or does the character on top of the stack not match our current character? And if either of these things are true, we're going to return false. Finally, we return if the stack is empty or not. All right, and so we get a runtime in 1 millisecond. It's faster than a majority of the Java solutions. And now let's look at the time complexity of this code. So looking at our loop, we have something going from I equals 0 to s.length. And inside that, we're doing constant time operations because pushing onto a stack is constant time, isEmpty is constant time, pop is constant time, and car at is also constant time. And so this whole statement is going to be executed n times, where n is the length of the string. And so our time complexity is O of n, and our memory complexity is also going to be O of n, because we're making a stack that scales with proportion to the number of characters inside scene. All right, and that's how you do the isValid problem on LeetCode. If you have any questions, leave them in the comments. If you learned anything, don't forget to like and subscribe. And as always, have a great day.